Let me start the record. Let's have a look at this. Can you read this okay, or you need me to blow it up? Let me blow it up one more. There we go.
Okay, sounds good. Okay, that's good. Okay.
The top part, the top paragraph.
Yeah.
Hold on a minute. F of t is the percentage a person remembers of the material. Okay?
Yeah.
In other
Yeah.
words, if f of t is 100, then you've memorized 100% of the material. If
Yeah.
f of t is 50, then you've only memorized 50%.
Yeah.
Okay? So here they're giving us f of t. Let me write it over here. It's this complicated thing, but don't get confused by the complexity of that. And
Yeah.
it merely tells you that the domain has to be between 0 and 12.
Okay.
And t is in months. Okay? So notice that if t were 0, in other words, immediately after you review the material, you're going to understand 85, the natural log of 1 is 0.
Yeah.
So this whole thing becomes 0. You're going to know 85% of the material right after reviewing it.
Okay.
And the more time passes, the less you're going to remember. Because
Yeah.
as t goes up, this, what I'm subtracting, becomes greater as t increases. So at some number of t, you're going to remember like 75% total. At some number of t, you might only remember 50%. So the more time that passes, the less you tend to remember.
Yeah.
All right, so let's look at what they want here. Graph the function over the domain.
Yeah.
Well, first of all, what does y equal natural log of x graph as? Graphs something like that, right?
Yeah.
Okay, so it's all we have to figure out is how that has been transformed. Well, graph the very first request is graph it over that domain. Well,
wouldn't there be like a reflection?
It would, but I'm going to rewrite it because it's easier to see the reflection that way.
Okay.
If I rewrite it like this, now we can see that it's more in a form that's been translated and reflected and all of that, right?
Okay, yeah.
So always do the reflection first. So if this is the normal looking y equal natural log of t.
Well, would it reflect over the y-axis?
Well, it would. The first thing, not the y, the x. When the negative sign is in front of the function, the parent function, it's a vertical reflection.
Okay.
So the very first thing I'm going to do is reflect this thing so that it looks like this. I'll reflect it in red. Still goes through that point.
Yeah.
And notice this looks a lot more like the model. In other words, as we remember quite a bit at t equals 0. But as
Yeah.
t gets bigger, we're going to remember less and less and less.
Yeah.
Okay. Now, what else kind of transformation are we looking at here?
Well, we also have a,
Consequences of the plus one inside the parentheses.
oh, well, that would be a horizontal shift.
Which way?
Left one.
Okay.
Left one.
So I'm going to draw that in green. Okay. What's the consequences of the plus 85?
That's a vertical shift up 85.
Okay. So if this is, say, 85 right there, then it's going to look something like that, right?
Yeah.
Okay. So, and then the 8 is a stretch factor, a vertical stretch factor. But that's hard to know what that looks like when you're looking at a reflected natural log curve.
Yeah.
Okay, it just means it's a little steeper. Well, you
Yeah.
can't really tell how steep I drew this one.
Yeah.
But the one thing I know about this curve is that when time is 0, the amount you remember is 85%. In other words, when t is 0, that whole thing goes to 0 because the natural log of 1 is 0.
Yeah.
So if I go back down now, and let's erase these other curves that I don't need anymore. It's the blue curve that goes through this proper point, and that blue curve is correct. Now, they said graph it only over the domain. Well, the domain is when t is from 0 to 12. Hold on. So we'll call that 12. So
Okay.
they only want us to graph it through that point and from that point. So if I erase the rest of it, what I have is something that looks like that.
Yeah.
Okay, so that's graphing it. Now use the property of logs to write the function in another form. Well, wow.
Yeah.
What?
Would you,
Okay, there's only one other form I can imagine.
what are you thinking?
Well, what I'm thinking is we can't change that. In other words, there is no other form for a natural log of two things being added. If the t and the 1 were being multiplied, then it would be the natural log of t plus the natural log of 1. So
Yeah.
I can't do anything with that. But this 8, what can I do with that 8?
Um, can't you, divide by 8, like divide 8 by both
Turn
sides?
it into an exponent. In other words, if I have 8 natural log of that, that's the same as the natural log of that argument raised to the 8th power. In other words,
Oh, yeah.
always take that leading coefficient and move it to the top.
Okay.
If I want to rewrite that in black, then one way to do it is 85 minus the natural log of t plus 1 to the 8th power.
Okay.
That's the only other way I can think of to rewrite it using the property of the logs.
Okay, yeah.
That property being the log of a to the b is equal to b times the log of a. So we
Okay.
were given this format, so we're going to move the b to an exponent of the argument.
Okay.
Okay? And it's still positive because I left my negative sign there. So it's not negative 8, it's positive.
Yeah.
Okay? What was the average score on the original exam?
Well,
I have no idea how to answer that. What was the
yeah,
average score on the original exam?
Yeah, huh.
Well, let me reread the first paragraph. $85.
Yeah, would that be the
Yeah,
original one?
if this function is correct, well, on the original exam is the one they took when t was equal to 0, right?
Yeah.
It's not the exam they took 6 months after reviewing or attending the lectures. It was the exam they took right after attending the lectures.
Yeah.
So the average score is going to be when t equals 0. And if you evaluate this function and figure out what f of 0 is, it's 85, because this whole
Yeah.
term disappears.
Okay.
Okay? What was the average score after 5 months?
Wouldn't you just plug 5 for t?
Yes, exactly. In other words,
And
what
then,
they're asking is, what is f of 5? Well, what is it? 85 minus the natural log of 6 to the 8th power. I don't really need to write it this way that they suggested. In other words, I prefer actually writing it in the original form. It's easier to calculate from a calculator.
yeah.
That's an easier number to come up with than the natural log of 6 raised to the 8th power.
Yeah.
So I would use the original format and just plug in 5 for t. And that's going to give you a number. I don't know what it is, but it's not particularly important. But that's what the students averaged after 5 months. That's how they got this equation.
Okay.
Empirically determined. And then after 12 months would be whatever that is, f of 12. So what's the equation going to be?
It's going to be 85 minus 8 times the natural log of 12. Or no, the natural log of 13, right?
Correct. So that's the average score after 12 months.
Okay.
Determine when the average score will decrease to 75. Well, how do we solve that? Remember what f of t is. F of t is the average score.
Yeah. Well, would we set would we set f of t equal to 75?
Exactly. And then we go back to this original equation. 85 minus natural log, I keep wanting to write natural log, strangely. Natural log of, and in fact, I'm going to leave that 8 in front of there like that. So now we got to solve that equation. Let's go through how we solve this for t, because that's what they're asking. At what t is f of t equal to 75? Well, we got
well,
this
for starters,
of it, but this is not exactly a piece of cake to solve. So first thing, solve that.
Well, we could subtract the 85.
Okay, so now I got minus 10 equals minus 8 natural log of t plus 1. Now what?
Well, then we would have to divide the 8 out.
Okay, so now I got 5/4 positive equals natural log of t plus 1.
Well, couldn't we natural log the other side as well in order to
Well, here's the thing. If you have an exponential equation, you solve it by taking the natural log of both sides. If you have a natural log equation or a log equation, You solve it by converting it to exponential format.
Okay.
Okay? In other words, if I told you that 10 is equal to the natural log of t plus 1, what does that mean? It means if I take the base e, raise it to 10, I get t plus 1. And then I can solve that for t, right? T would be equal to e to the 10th minus 1. So that's how we solve it. So let's convert this to an exponential equation. So it's e to the what?
Would it be e to the 5/4?
Equals
t plus 1.
Which means e to the 5/4 minus 1 equals t.
Yeah.
That's when, and that's just a number. In other words, you can get this number out of your calculator. Right?
Yeah.
What kind of calculator do you have?
I have a TI Inspire.
Okay.
I already solved it.
You have a button on there for e, just like you have a button for pi.
Yeah.
And just take e, raise it to the 5/4 power. Or,
and then subtract it by 1.
1.25 if you prefer.
Yeah.
Subtract that's your answer.
It's 2.49.
Sounds right. Which means that after 2.49 months, the average student has retained 75% of the original material.
Okay.
So we can see it's going down, as we would expect.
Yeah.
Because at the beginning, everybody averages retaining 85% of the material. So as time passes, between 0 and 12 months, you're going to retain less and less. So this answer makes a lot of sense, that after 2.5 months, you would be retaining 75% of the material.
Yeah.
Okay. What conclusion can you make about this model? Well, these are always subjective questions. The conclusion is that people forget information with time. I guess. I don't know what they want for an answer for E. I really don't.
Yeah, I'll just kind of make something up.
Well, and you could make up a number of things that would be true. It'd be hard to argue with. I don't think you'd get anything as long as your conclusion is correct, which is that you retain less and less material as time passes.
Yeah.
If I teach you the quadratic formula right now, you're going to remember it an hour from now.
Yeah.
A year from now, you might not.
Yeah.
So it's natural that people lose retention of material as time passes.
Yeah.
That's the conclusion you would make. I don't know if they want more than that or not, but it's not worth spending our time on.
Yeah.
Trying to figure out what it is they're wanting. That's not a number. They want a subjective thing. All right, so let's look at the next one. The number y of endangered animal species can be modeled by that. Y equals minus 119 plus 164 natural log of t, where t is between 10 and 22 inclusive. T equal 10 corresponds to the year 2000.
Okay.
So how do I answer? Is this the only question they have here? And in what year did the number of endangered animal species reach 357?
Yeah, that was the only one they had on that question.
So what should I write?
Well, wouldn't you set y equal to 357?
Correct. And now again, you have this thing you have to solve. And this is a logarithmic equation.
Yeah.
So the secret is to narrow it down to just that on one side of the equation and then convert it to exponential. which you'll be able to get the answer out of your calculator then.
Yeah.
So how do we narrow it down to just that on one side? What's the first thing we're going to do?
Oh, well, to start out, we just add the 119 to both sides.
So that's 476 equals 164 times the natural log of t. What next?
Well, next we would divide 164.
Okay. I don't know. You suppose that goes in there an even number of times? Do you have your calculator handy?
Yeah. I have my calculator, but it doesn't come into like an even amount of times.
That's all right.
It reduces down to yeah, it goes down here.
Must be 3.
It goes to 2.902.
Okay.
But if you leave it in fraction form, it'd be 119 over 41.
Which is exact.
Yeah.
So we want to leave it 119 over 41. That's not rounded off.
Okay.
And that's equal to the natural log of t. Okay? So now we have a natural log equation, or we have a log equation. You solve log equations by converting it to exponential format. What's the exponential expression here that we need?
Would it be e to the 41 over, or no, e to the 119 over 41?
Correct.
Equals t.
That's it. In other words, the way I usually think of this, let's take a whole different one here. Let's say I had the log base 7 of x equals 10. Okay? There's a log equation right there.
Yeah.
I don't know what x is. X is between 1 and 2, has to be.
Yeah.
But the way I solve this is by converting it to exponential. And the way I remember it is I take the number on the far left, raise it to the power on the far right, and it's equal to the thing in the middle. So I get 7 to the 10th equals x. Very big number. Well, they're screwing with you a little bit by putting the log on the right side of the equation.
Yeah.
In other words, you still need to be able to convert that top row that you see there into an exponential. So it's really the base raised to the power of what's on the other side of the equation equals the argument.
Okay.
So it's not really correct to remember the far left raised to the far right equals the middle, because sometimes they give it to you like this, where it's not far left and far right, it's the base raised to this power equals the argument.
Okay.
Okay? And there's a number for you. You can get that number.
Okay, yeah. It's
Yeah, go ahead and come up with it. Let's make sure it makes sense. It's It's close to e cubed. Well,
yeah,
it's got to be less than 27. It's probably
it's 18.21.
Yeah. And it really does help to be able to kind of know approximately what it is. In other words, e is 2.7, right?
Yeah.
Well, if I had 3, and that's close to 3, if I had 3 cubed, that'd be 27. Well, I got a smaller base and a smaller exponent, so it's got to be less than 27. 18.21 sounds about right, because if I had 2 cubed, it would be 8. So 2.7 approximately cubed, that looks exactly like where I would expect it to be.
Yeah.
So after 18.21 years is when they will have the endangered animal species be at 357.
Okay.
Now, we got to go back, and they said that t equals 10 corresponds to the year 2000. So t equals 18.21 corresponds to what year?
Would that be
t equals 11 would be what year?
wouldn't that would just be 2001, right?
If t was equal to 11, yes. But
Yeah.
we got a t equal to 18.21. What year is that?
Well, that'd probably be like 2008.
Exactly. Sometime in the middle of 2008, between the start of the year and the end of the year, the number of endangered animal species is going to reach 357.
Yeah.
Specifically at about February of 2008.
Yeah.
Because we have to go 8 years beyond 2000
And then
plus 0.21.
Yeah, yeah, the
Couple
point two would
months.
just be in
Yeah, it's a
line.
couple of months. So that's into
Yeah.
February.
Yeah.
All right. So that should take care of you there.
Yeah.
Yeah, the most important thing to remember when you're solving either exponential equations or log equations. In 3 minutes, let's just go through a couple.
Okay.
I said to you that 2 to some power is equal to 7. I do not have an algebraic way of solving for x.
No, you don't.
You don't either. In your calculator, you couldn't even do it.
No.
But we have an exponential equation here. You solve exponential equations by taking the logs of both sides. So if I take the log of the left and the log of the right, now that allows me to bring that x out of the exponent and write it like this.
Okay.
Now these are both just numbers. So if I divide both sides by natural log of 2, there's my answer. Whatever that number is. So you solve exponential. This is what we started with. That's an exponential equation. And we solved it by logs.
Yeah.
On the other hand, if I said to you the natural log of 6 equals x, I don't know how to solve that either. But if I convert it to exponential, in other words, you always convert it to the opposite of what it is. If it's a log equation, you convert it to exponential. If it's, hold on a minute. I didn't mean to write it like that. Just a second.
Oh.
That's not very helpful. This would be helpful. Okay?
Okay, okay, yeah, that makes...
What exponential can you write from that?
Couldn't you do, e to the 6th is equal to, x?
And that you can get out of your calculator.
Yeah.
So always remember that if you're solving log equations, you need to isolate the log expression and then convert it to exponential format.
Okay.
If you have exponential format to begin with, you're going to need to take the logs of both sides and solve it that way.
Okay.
Assuming that the variable is in the exponent. When I say exponential format, I mean something like where the variable is in the exponent.
Okay.
In other words, if I had that, I can't solve that. I have no idea what x would be.
Okay.
So the way I solve it is by taking the log of both sides, and that allows me to bring that exponent, the variable which is in the exponent, around in front. Now I have x natural log of e equals natural log of 7, and I can solve it. The natural log of e is what?
The natural log of e is
1.
Oh.
Always. In other words, hold on. I think I can do that. Yeah. In other words, the natural log of e has a base of e, right?
Yeah.
Well, whenever you have the log base b of b to the x power, that's always equal to x, because that is always 1, no matter what b is.
Okay.
Okay? So that's why when you bring the exponent down in front, it's multiplied by the number 1. So it's just equal to x.
Okay.
All right, Peyton.
Yeah, sweet. Thanks.
You're welcome. Hope that helps.
Yeah, it did.
Talk to you next time.
Yeah, I'll talk to you next time. See ya.